Okay, tonight we're doing chapter 4, and this is the metric units, and applying them to figuring out our dosages. If you go to page 100, we're going to just go over a couple of these problem sets. 1 through 10 is just asking for the abbreviations of the metric units. Like number 1 is microgram, which is MCG, and those you can find in your chart in this chapter, so that's just what you would do for those. 11 through 20 is asking you to change those numbers using an Arabic number with a decimal value and the appropriate abbreviation. So we've got the number written out. Number 11 says 6/10 of a gram. Anytime you see 6/10 or hundredths that ends in THS, that means that your number is going to go after the decimal point. So when you have number 11, 6/10 of a gram, we always begin with our 0, and the tenths place is right after the decimal. So then our abbreviation for gram is G. Number 12, 50 kilograms. 50 is normal 50. And this is kilograms. Number 14, 400ths of a liter. So that means it's going to go after our decimal again. 0.04, because this is the hundredths place right here. And then liter is L. Next question we're going to go over is number 21. 21 is telling us that the Taro Pharmaceutical Company has donated a container of 5 kilograms of bulk genocillin granules. The standard dose is 375 milligrams, so how many single dose units can be obtained from this container? So I wrote down that we know they donated 5 kilograms, and that a single dose unit is 375 milligrams. So to figure this problem out, we first need to convert our kilograms to milligrams. So they gave us 5 kilograms, and that equals 5,000 grams, because there's 1,000 grams in 1 kilogram. But there's also 5,000 milligrams in 1 gram, so we would multiply the 5,000 by 1,000 again, which would give us 5 million milligrams. So in that 5 kilograms that they gave us, there's 5 million milligrams. Now to figure out the amount of single dose units, we would have to take our 5 million and divide it by 375 milligrams, and that would give us 13,333.33, and we would always round that down because 0.33 isn't a whole one, so when it's asking us how many single dose units, we have to give them the whole amount. So even if that was 13.3 or 13,333.8, that's still not a whole dose, so you wouldn't count that as one. You wouldn't round up. You would always round down. So your answer would be 13,333. Okay, the next problem is number 22. And this problem says the pharmacy receives the following prescription: levothyroxine tablets, 0.05 milligrams. They're taken 2 in the morning, which is this, 2 in the morning, 1 with lunch, 2 at 8 p.m., and that they're getting a 30-day supply. So part A is asking us how many tablets would be dispensed. So we first need to figure out how many they're taking per day. So they're taking 2 in the morning, 1 at lunch, 2 at 8, so 5 tablets per day. And then if they need a 30-day supply, multiply that by 30, and that is 150. So that's how many tablets we would dispense. Now, part B is asking how many milligrams the patient will get over the course of 1 month. So we need to take the 0.05 milligrams, because that's what's prescribed, multiply that by 5, because they're taking 5 a day, and then multiply it again by 30 because they're having 30 days. And that should give you 7.5 milligrams. Okay, the next problem is number 24 that we're going to go over. It says a patient is to receive 1.2 grams of cimetidine per day in 4 divided doses. So part A is asking how many grams will be in each dose. So we need to take 1.2 grams that they're getting in one day and divide it by 4 because they're taking it in 4 divided doses. And that should give us 0.3 grams in each dose. Now part B goes on to ask that if the available dosage forms are shown in the following labels, what would be chosen? So we need to choose between cimetidine 300, 400, and 800 milligram tablets for what we would dispense. And in order to do that, we would need to change our 0.3 grams to milligrams. Now, we know that 1 gram is equal to 1,000 milligrams. And we're trying to figure out how many milligrams is in 0.3 grams. So we'd solve for x. And when you cross multiply and divide, you should get 300 milligrams. So we would choose a cimetidine bottle with 300 milligrams in it. Alright, now we're going to move on to 4.2. And I would really like you guys to read this chapter thoroughly, or this section, because it's going to tell you 3 different ways to convert these units, and I want you to choose the way that you like to do it best. For the purposes of this chapter, we're going to kind of go over it all 3 ways, but for your test on Monday and for your national exam when you take it, it's not going to tell you a certain way you have to do it, so I'd really like for you just to find your favorite way and just get the right answer. So, numbers 1 through 10 are asking you to convert the units using the ratio proportion method that we've been doing. So, we'll do number 1. It's telling you that they want you to convert 1964 micrograms to milligrams. So, start out with what we know, which is our conversion factor. 1 milligram is equal to 1,000 micrograms. So we're trying to figure out how many milligrams is in 1964 micrograms. And when you cross multiply and divide, like we've been doing, it should be 1.964 milligrams. Now number 2, they want you to change milligrams to grams. 418 milligrams. So we got 1 gram is equal to 1,000 milligrams. So we're changing it to grams. We have 418 milligrams. Cross multiply and divide, and you should get 0.418 grams. And always remember what I said about leading with your 0. Because if you don't put your 0 there, that decimal might get missed. And instead of a pharmacist giving out 0.418 grams of this medication, they might give out 418 grams. And that would definitely be a lethal dose. Alright, now we're going to move on to numbers 11 to 20. And these are, I have them written out here, numbers 11 and 12. Let me actually erase this so you can see me write it out. Okay, numbers 11 and 12 we're going to do, and they're wanting you to do it using a dimensional analysis method, which is kind of like the ratio proportion method, but multiplying it a little differently. We haven't went over this one. It might be a little confusing. So if you don't like this one, you can answer these questions however you want to. Like I said, I want you to just get the right answer. But for the purposes of this, it's 52 mLs. You're converting that to liters. So then you would just multiply that by your conversion factor, which would be your 1 liter over 1,000 milliliters. And your answer should then be 0.052 liters. Number 12 is the same way. You're taking your 2.06 grams and you're multiplying it by your conversion factor, which would be 1,000 milligrams over 1 gram. And that gives you 2,060 milligrams. Alright, 21 through 40 is asking you to just do it using the method that you prefer or by moving the decimal. Moving the decimal with percentages, either 2 places to the right, 2 places to the left, is pretty simple, but when you're getting into changing things like micrograms to grams and you're having to move it 6 and 7 and 8 places, it gets a little insane. So I probably wouldn't recommend doing that unless you just know them off the top of your head, or if it's something smaller like micrograms to milligrams where you're only having to go 3 places. Honestly, I'd probably stick to the whole ratio proportion method that we've been setting up and solving for X. It seems like that's the universal way and the easiest way to understand it. But for this, I can do number 26, moving the decimal. It's just giving you 5,000 micrograms. Oh, I'm sorry. Micrograms. I want you to change it to milligrams. So milligrams are bigger than micrograms. So you know that your answer is going to be smaller than that. So you would move it to the left. So your decimal place on the whole number is here. And since there's 1,000 micrograms in a milligram, you would move it 3 places. Be 1, 2, 3. Your answer would be 5 milligrams. Alright, number 41. The following prescription has come into the pharmacy. Clarithromycin, 125 milligrams per 5 mLs, 2 teaspoons twice a day with food or fluid for 7 days. And it says to note that 1 teaspoon is equivalent to 5 milliliters. So it's asking you how many milliliters will the patient take daily. Alright, so they're taking 2 teaspoons times 2 times a day. 2 times a day. And that equals 4 teaspoons per day. But it's asking us how many milliliters. So if in our note 1 teaspoon is equal to 5 mLs, we would do 4 times 5, because they're taking 4 teaspoons a day, times 5 mLs. That would equal 20 mLs per day. Now part B is asking you how many milliliters would be dispensed for the patient. So if they're taking 20 mLs per day, and they're wanting us to do this for 7 days, we'd multiply it by 7 days, and that should give us 140 mLs. That's how much we would need for 7 days. Now, part C is asking us how many grams will the patient take daily. So they're taking 20 mLs per day. and there's 125 milligrams in 5 mLs. So we would do 125 times 4, which is, sorry, I got a calculator, which is 500. 500 milligrams. Wait, I think I did that totally wrong. I'll back up here. Okay, they are taking 20 mLs per day. They want to know how many grams the patient's going to take. There's 125 milligrams in 5 mLs. They take 20 mLs per day. I need to know how many grams is in 20 mLs. So that was right, yep. 125 milligrams per 5 mLs. We take 20 mLs. So we can kind of do the X thing over 20 mLs. And solve for X. 20 times 125 divided by 5 is 500. So they're taking 500 milligrams per day. The only problem is they want to know how many grams they're taking per day. So we know that there's 1,000 milligrams in 1 gram. They're taking 500 milligrams, so we need to know how many grams that is. And that should be 0.5 grams per day. Part D. Using the following drug label, how many bottles of clarithromycin need to be dispensed to fill this prescription? So, we know that Part B, our answer was 140. How many milliliters should be dispensed for the patient? They want to know how many bottles need to be dispensed. On this label, there's only 100 mLs per bottle. One thing to know with this antibiotic stuff, those suspensions, if you've ever gotten a suspension antibiotic filled, they don't split the bottles up. They give you the whole things because they go bad anyways in 10 days. So if there's 100 mLs, they would just automatically give you 2 bottles. And there would always be a note on there to throw the remainder away. Alright, problem sets 4.3. We're on page 112. We're calculating the following doses using the ratio proportion method, which is what we've been doing: cross multiply, divide, solve for X. Number 1, a patient has a prescription order for 30 milligrams of a drug. The pharmacy has a partial container of 7.5 milligram tablets. How many tablets will the patient need? So, if we have 7.5 milligram tablets on hand, that would be 1 tablet is 7.5 milligrams. But our physician ordered 30 milligrams. So we need to know how many tablets are needed to get 30 milligrams. If you cross multiply and divide that, you will get 4. So the patient would need to take 4 of the 7.5 milligrams to get their dose. Alright, number 2. A prescription order is written for 20 milligrams of medication. Pharmacy has on hand a 10 ml vial of 25 milligram per 2 ml solution. How many milliliters will be prepared for this patient? So the strength of our solution is 25 milligrams per 2 mLs. But our physician ordered for our patient to get 20 milligrams. So put our 20 milligrams up here so they match. We need to know how many milliliters our patient needs to get their 20 milligrams. So when you cross multiply and divide, 20 times 2 divided by 25, you get 1.6 mLs. Number 3, a patient is prescribed 25 milligrams of carbamazepine suspension. The label provided shows the drug that the pharmacy has in stock. How many milliliters will be prepared for this patient? Carbamazepine suspension, 100 milligrams per 5 mLs. That's right on our label. Now our doctor prescribed, I'm sorry, I said 25. It's 125 milligrams. So you know how many milliliters we need to get 125 milligrams. Cross multiply and divide, you get 6.25 mLs. Now if you guys want to go through and do the rest of these, or some of them, the odd ones, the even ones, however you might want to do it, and contact me if you have any questions. Obviously won't be able to go through all of them, but they're all going to be found the same way. You're just going to set up your proportions. Okay, 4.4 is where it gets a little bit tricky. We're going to be calculating doses based on weight, and that would be like our body mass, our body surface area. And there's also 2 other ways, which are the Young's rule and the Clark's rule. Now, the body mass, or the body, I'm sorry, I keep saying it wrong. The body surface area weight may not be as important, but the Clark's rule and the Young's rule, I can guarantee you, is going to be a question on your test and on your national exam. So you need to know those 2 rules. They're very, very important. Alright, with problem sets 4.4, you're going to be using the little charts that are on page 118 and 119, and that'll be for the questions 1 through 10. And this is using the nomogram to determine the following BSA values. I don't think that those are on the test at all. I'm not going to put it on your test on Monday. But basically, to use these charts, you're going to follow the steps that are on page 117. So you're going to mark the patient's height on the left column and their weight on the right column. And then you're going to line those 2 dots up with a ruler or something straight, and mark where it crosses through the middle column, the body surface column, and then that's your answer. And it says for the homework purposes to round it to the hundredths place. So number 1, it's telling you the child is 28 inches and 20 pounds. So you would use figure 4.2 because it's the body surface area of children. And on the height, you would put a dot on 28 inches. Make sure you put it on the right side of the column, under inches and not centimeters. And then their weight is 20 pounds, so you'd put a dot there. And you would put something straight there to connect those, and it should cross at 0.41 meters squared. And that would be your answer. So you do those for 1 through 4. Once you get to 5 through 10, for young adults and adults, you're going to use figure 4.3. So you do the same thing there. Adult, 60 inches, 78 kilograms. Put the dots on both of those and go through it. Oh, sorry. Number 1 is 0.41 meters squared. So then number 6 if you put your dot at 60 inches and 78 kilograms and see where it crosses in the middle, it would be 1.75 meters squared. Is your answer there. Alright, for numbers 11 through 17, you're going to calculate the following weight-based doses based on the provided recommended dose. For homework purposes, round to the hundredths place. Cortisone is dosed at 0.5 milligrams per kilogram. The patient weighs 56 kilograms. We're just going to set these up in proportions just like we did before. It's the easiest way. So what is the dose? So then you would do the 0.5 times 56 divided by 1, because if there's no number here, then it's just assumed to be 1. And then your answer would be 28 milligrams. Number 2, a post-surgical patient is to receive 125 milligrams per kilogram per day of cephalosporin divided into 6 doses daily. What will each dose be for a patient weighing 87 milligrams? Or 87 kilograms, I'm sorry. So then you would do 87 kilograms times 125 divided by 1. That would be 10,875 milligrams per day, because it's telling us that our patient's receiving 125 milligrams per kilograms per day. But our question's asking us what will each dose be. They're taking 6 doses, so they would have 10,875 divided by 6, and that should equal 1,812.5 milligrams. Alright, moving on to 18 to 22. You're going to calculate the following BSA-based doses to provide the recommended dose. So we're basically doing the same thing, we're just using different units. The patient is receiving medication with a dose based on 25 milligrams per meter squared per day, divided into 2 doses. The patient has a BSA 1.1 meters squared. So how many will each dose be? So they're getting 25 milligrams per meter squared per day. That would be 25 times 1.1. 25 times 1.1. And that would be 27.5 milligrams per day. Now we're wanting to know what the dose is. So they're taking 2 equal doses, so you divide that by 2. And that should equal 13.75 milligrams per dose. Number 19, a patient is to receive medication with a dose based on 0.75 milligrams per meter squared. Patient has a BSA of 0.67 meters squared. How much medication will you prepare? So you just take the 0.75, multiply it times 0.67, and that equals 0, round to the nearest tenth, 0.5 milligrams. Alright, 23 to 26, we're determining if the following doses are safe. Number 24, our patient weighs 27 pounds and is 30 inches in height. So we need to figure out what this patient's BSA is first. If we put our dots at 27 pounds and 30 inches, the BSA is 0.48 meters squared. Okay. The manufacturer of methotrexate has recommended a dose of 3.3 milligrams per meter squared. The physician has ordered 2.5 milligrams of methotrexate. So, the recommended dose is per meter squared, so got to match it up, is 3.3 milligrams. So we need to do 0.48 and times it by 3.3. And that equals 1.584 milligrams. This is what they should be getting if they'd use the recommended dosage from the manufacturer. If you keep reading, your physician has ordered 2.5 milligrams of the drug. So we need to know if it's safe. With our patient with a body mass index of 0.48 meters squared, they should be getting a dose of 1.584 milligrams. Our physician ordered 2.5 milligrams, which is higher than the recommended dose. So we would say that that is not safe to give our patient. Alright, let's do one more like that. Our pediatric patient weighs 23 pounds and is 32 inches in height. If we put that in our body mass index chart, we get 0.47 meters squared. The manufacturer recommended a dose of 250 milligrams over our meter squared every 8 hours. So we need to figure that out here. We would do 250, multiply it times 0.47, and that should equal 117.5 milligrams. This is what our dose should be for a patient of this size. Our physician ordered 200 milligrams 3 times a day, which is every 8 hours. Which is higher than what is recommended by the manufacturer. So we would say that this is not safe for our patient. Alright, 27 to 32. It's basically the same thing. We're just doing it more as ranges, but we're figuring things out the same way. Number 27 tells us that our pediatric patient weighs 36.4 kilograms and is 48 inches in height. Our manufacturer of cefazolin recommended a dose of 50 to 100 milligrams per kilograms per day. The physician has prescribed 250 milligrams. Now, don't let questions like this throw you off, because they will. You might think you need to calculate the BSA because it's telling you their height and their weight, but you don't have to do that, because our recommended dose is 50 to 100 per kilogram, not per meter squared. So the only thing that you really need to know in this problem is the 36.4 kilograms, which is how much our patient weighs. Okay, so calculating the minimum daily dose for this pediatric patient, for part A, we would use the smaller number. So the 50 to 100 milligrams per kilogram per day, we would use the 50 to calculate the minimum because it's smaller. So we'd set this up like this. This is our X milligrams to see what our range would be. Our minimum daily dose. So we have 1 kilogram over 50 milligrams. So we would take our 36.4 and multiply that by 50. And X would equal 1,820 milligrams. And that is our minimum daily dose. Now part B is asking us to calculate the maximum daily dose. So we have our 36.4 over X. Doing the maximum, we would use the 100 because that's our, we need to make sure our stuff lines up. So a kilogram, 100 milligrams per kilogram. X would equal 36 times 100, 3,640 milligrams would be our max dose per day. Alright, part C is the physician dose within the recommended safe range. Okay, our physician has prescribed 250 milligrams 3 times a day. 250 milligrams 3 times a day, we'd multiply that by 3. 250 times 3. That would equal 750 milligrams. This is what he ordered. So our recommended minimum is 1,820 milligrams, and our recommended maximum is 3,640. So if we have 820 milligrams to 3,640 milligrams, is this within this range? And no, it is not. It is under the recommended dose. Part D wants to know how many milliliters will be prepared for one prescribed dose if the product is available as 500 milligrams per 50 mLs. Okay, so we got 500 milligrams per 50 mLs of our solution. This is just going back to what we did a few minutes ago. Alright, our dose the physician prescribed is 250 milligrams. So we would solve for X here. And X would be 25 mLs. We would do 25 mLs per dose. Alright, number 29, we're going to do one more of these. Pediatric patient weighs 11.8 kilograms and is 31 inches in height. Physician has ordered acetaminophen with codeine, and the safe dosing of acetaminophen with codeine is based on the amount of codeine. The manufacturer of codeine has a recommended dose of 0.5 to 1 milligram per kilogram per dose. The physician has ordered 10 milliliters of 12 milligrams of codeine per 5 mLs oral elixir. So we're calculating the minimum daily dose for this pediatric patient. Okay, so we know that our pediatric patient is 11.8 kilograms, and that's what we would use because our recommended dose is using milligrams per kilogram. Minimum daily dose was 0.5 milligrams per kilogram. And our patient weighs 11.8 kilograms. So we would do 11.8 times it by 5. 11.8 times by 0.5. And divide it by 1, so X would give you 5.9 milligrams is our minimum daily dose. We do the same thing with our maximum daily dose. Maximum daily dose is 1 milligram per kilogram. Our patient is 11.8 kilograms. So solving for X would be 11.8 milligrams. How many milligrams of codeine are in 10 mLs of oral elixir? There's 12 milligrams in 5 mLs of our elixir, and you find that in the problem. And we need to know how much is in 10 mLs. So we set up the proportion, solve for x, and that would be 24 milligrams per 10 mLs. Is the physician's dose within the recommended safe range? Our physician prescribed 10 mLs, so they prescribed 24 milligrams for us. Our recommended range was 5.9 to 11.8 milligrams. So this is higher than this. It is not within our range. Alright, the last problem is number 33, and it's using Clark's rule and Young's rule. Young's rule is based on the suggested dose of a child's age, and Clark's rule is suggested on the child's weight. So you get different dosages depending on what rule they ask you to use. Number 33 is saying that an 8-year-old child weighs 68 pounds, which is 30.9 kilograms, and is to take a cyclovir, which has a normal adult dose of 600 milligrams. So, part A is asking us to use Young's rule to give the appropriate dosing. Young's rule is on page 121, and it wants you to have the age, which our child is 8 years old, over the age plus 12 years. So it would be 8 plus 12, and then multiply it by the adult dose, which would be 600. And that gives you, first you add the 8 plus 12. So it would be 8 over 20 multiplied by 600. 8 over 20 is 0.4 multiplied by 600, and that gives you 240 milligrams. So according to Young's rule, our pediatric dose for this should be 240 milligrams. Now part B is asking you to do the same thing using Clark's rule. Clark's rule wants to use our weight in pounds. So if your problem gives you in kilograms, you have to use pounds. And that's why they're trying to throw you off here by giving you the kilogram weight and the pound weight. Make sure that you use the pound weight. So we would do 68 pounds over 150 pounds. And this is just a standard, it'll always be 150 under there, multiplied by the adult dose. And that gives you your answer. So we need to do 68 divided by 150 multiplied by 600. And the answer would be 272 milligrams. So using Clark's rule, your pediatric dose would be 272. Okay, that is it for this chapter. For your homework, you need to do all of the chapter review, the comprehension, sampling certification exam, and the practice test. And please, like I said, text me, call me, whatever you need to do to get in touch with me with any questions. Your tests will be on chapters 1 through 4. I'm going to write this down. 1 through 4 math. Chapters 1 through 5 Blue Book. chapters 3 through 5. Those are the main ones. And then the pharmacology with the central nervous system, endocrine, and cardiovascular. And for those, you need to just know mainly the grand generics, and which system that they're in. And like I said, do not hesitate to ask me questions, because I know it's difficult having this online. I tried making these videos. I don't know if they helped. I hope they did. But do the practice. Ask me for questions. Please, please, please. And thank you. I'll see y'all Monday.